represented by spring. And we have the formula. Work is represented by W equals the integral of f of x dx from a to b. Where f of x here represents now the force, k is constant of proportionality, and x is the displacement. And a and b are the limits of integration. And force is also defined to be k times x. This is the spring. We call it as the natural length of spring. Now we have the length of spring as the natural length. And when this is now stretched, okay, so there is a displacement represented by x. So that's a displacement when this is stretched. And then when it is compressed, there is also a displacement, which is also x, okay? So this is stretch, while this is now compressed. Okay, the displacement here is x because this is the original or the natural length of the spring, okay? A spring is a natural length of 8 cm. If a force of 20 dynes stretches the spring 1/2 cm, find the work done in stretching the spring from 8 cm to 11 cm. Okay, so let us identify the given here. We have the natural length of the spring, which is 8 cm. And then there is a force of 20 dynes that stretches the spring 1/2 cm. So the 1/2 cm here is defined to be x, because that is the displacement. And this is the length where the spring is stretched. Okay? So it is 1/2 cm. So we're going to find the work done in stretching the spring from 8 cm to 11 cm. Okay? So in order for us to define the work done in stretching the spring from 8 cm to 11 cm, we need to find first the integral, which is represented by f of x. Okay? And that f of x here, by formula, we have this as kx. So we have force here applied, which is 20 dynes. Then we have k, which is the constant of proportionality. Then x is 1/2. So solving now for k, this is 40. Then, using now the formula, where we have now the f of x equals 40, because k is 40, okay? Then we have now 40x. So this is now the integrand that we're going to use to find the work done in stretching the spring from 8 cm to 11 cm. Okay? And what will then be the limits? The limits will be from, so since its natural length is 8 cm, and the displacement will be, okay, from 8 to 11, there's a difference of 3 cm, right? So therefore, the limits will be from 0 to 3. Okay? Then f of x will be 40x dx. So from here, let us now integrate. So that is now 40x squared all over 2 from 0 to 3. Okay? Then simplifying, we have this as 20 times the upper limit, which is 3 squared minus 0 squared. The work done would be 3 squared is 9 times 20, that is 180. And what will be the unit now? The unit will be in 9 centimeter, okay? So this is the work done for this given problem. Find the spring constant. And then find the work done required to stretch the spring 1.8 meters beyond its natural length. Okay, so question. Do we have the natural length given in this example? We don't have the natural length, right? So, what about this 1 meter here? This 1 meter is the displacement. Okay? Based from the problem, it says here, spring exerts a force of 5 newtons when stretched 1 meter beyond its natural length. So therefore, that is the displacement x. Okay? 1 meter. And then we have now the force, which is 5. So this is your f of x. Okay, so we're going to find the spring constant, and that is represented by k. And how do you find the spring constant? We have the formula f of x is equal to kx, okay? Where f of x is 5, then x is equal to 1, okay? So therefore k equals 5. What about the second problem here? Find the work done, or the second question. Find the work done required to stretch the spring 1.8 meter beyond its natural length. Okay, so we have here class the quantity, which is 1.8 meters. And how do you describe this 1.8 meter length? So that is also the displacement. Why? Because we have here, find the work done required to stretch the spring 1.8 meter beyond its natural length. Okay? So therefore, work is required here. Okay? And then, from the formula of work, where we have now integral of f of x dx from a to b, the limits will now be 0 to 1.8. Okay? Because this is the displacement which is represented by x. Okay? Required to stretch the spring, no? 1.8 meter beyond its natural length. So it's stated in the problem here. And f of x can be found by the formula, which is k times x. And k, we have a while ago determined it as 5, then we have this as x, okay? So let's have this now 5x dx. Then we have here now 5. Integrate now x dx, we have this as x squared all over 2 from 0 to 1.8. So therefore, the work done is equal to 8.1 Newton meter. So this is the work done in stretching the spring 1.8 meters beyond its natural length. Okay? It's here that a spring has natural length of 40 inches. It takes a force of 20 pounds to compress the spring to a length of 10 inches. How much work is done in compressing the spring from its natural length to a length of 10 inches? Okay. So a while ago, there are two problems that involve stretching the spring, right? So in this example here now, we have now the spring is being compressed. Okay? So that we have the given natural length. The natural length is equal to 40 inches. Okay? And then we have the force to compress the spring to a length of 10 inches. So that is the force f of x equals 20 pounds. Okay, so we have here now, it takes a force of 20 pounds to compress the spring to a length of 10 inches. So originally, this is the length. Okay, so let us have this as 14 inches. This is the natural length of the spring. Now class, since it is compressed, so this is now the length of the spring is now 10 inches. So in other words, we have the displacement, and the displacement is 4. How is this obtained? You can have it from We have 14 minus 10. Do you follow? Okay. So with that, let us now define the k. Okay? So based on the formula that we have, f of x equals k times x. And f of x is equal to 20, then x is equal to 4. Okay? So therefore k equals 5. So then what do we have here? How much work is done in compressing this spring from its natural length to a length of 10 inches. Okay, so with that, we have the work done being required, and then the formula would be integral of f of x dx from a to b. So let us now use f of x. F of x is k times x, where we have now k is 5. Then this is now x, okay? So we have 5x dx. So what will then be the limit? So it says here how much work is done in compressing this spring from its natural length to a length of 10 inches. So therefore, so this is the required, right? The work done to compress the spring from its natural length, which is 14 to 10 inches. So therefore, the limits will be from 0 to 4, okay? And with that, let us have now this as 5. Then think of x dx is x squared all over 2 from 0 to 4, okay? Then this is now 5. Then 4 squared is 16 all over 2, that is 8. So the work done is equal to 40. The unit will be pounds, inches. Okay? So, do you have any problem? Find the work done in compressing the spring from 10 centimeter to 6 centimeters. Okay, so let us identify the given here. So first thing to do is to find k first, using the given. So solving now for k, we have this as 30 all over 6 or 5, okay? And then from here, we use now this constant spring to define the work done. And let us have the formula now. Work done is the integral of f of x dx from a to b. But what is f of x? F of x can be found from the formula kx, where we have this now as k is equal to 5, and then we have x. So that this is now 5 of x dx. So we have now the limits. What will then be the limits? Okay, so let us have the situation drawn plus. So let's have the spring. So suppose this is the natural length of the spring. So the natural length is equal to 15 centimeter. And we have the resulting compression of the spring, which is 6 centimeter. This is the x, okay? So this time we're going to find the work done compressing the spring from 10 centimeter to 6 centimeter, okay? So if we have this as the 10, and then we have this as so we have this as 10, and we have this as 6 centimeter. So what will then be the limits? So you can base it from the natural length. So this will be the upper limit. So 15 minus 6 will be 9, you follow? And this will then be the lower limit, which is say, and this is 15 minus 10 will be equal to 5. Okay? So therefore, that is now the limit. So from 5 to 9. Okay? Then we can now integrate this. So having this as 5, integrating x dx is x squared all over 2. Or we can now have this as 5 halves. Then apply the limits, that is 9 squared minus 5 squared. So continue, we have 5 all over 5 over 2, then you have times 81 minus 25. So the work done is 5 halves. 81 minus 25 is, you have this as 56. And 56 over 2 is 28. 28 times 5 would be 140. And the unit will be lines centimeter. Okay? So that is how we complete for the work done in compressing the spring from 10